In part C of this question, we need to find an expression in n for the number of matchsticks needed to turn the n-1th pattern into the nth pattern. So for this, we're going to use the table from the previous part, and we're going to be focusing on the number of matchsticks. Okay, so before going into this, let's get an nth term for our general term for the number of matchsticks. So the difference here, we have 6, 9, then 12. So that means a second difference of 3 in both of them. Okay, so we have a second difference of 3. Okay, so the general term for your quadratic is an squared plus bn plus c. And then the a term is always the second difference over 2. So in that one, our second difference is 3. So that means that a is going to be 3 over 2. So that means we have Tn is equal to 3 over 2 n squared plus bn plus c. So for the first term, so T1, so we have 3 over 2 times 1 squared plus b times 1 plus c, and this is equal to 3. Because 3 is the first term for the matchsticks. So we have 3 over 2 plus b plus c equals 3. So that means b plus c is equal to 3 over 2. Because 3 minus 3 over 2 would be another 3 over 2. Okay, so now the second term, so T2, 3 over 2 times 2 squared plus b times 2 plus c. This equals the second term now, which is 9. So 3 over 2 times 2 squared. So that'll get us 6 plus 2b plus c equals 9. So that means 2b plus c is equal to 3. So now we have two equations. And now we can solve a simultaneous equation. So we have b plus c equals 3 over 2, and then 2b plus c equals 3. Okay, I'll times the top by minus 1. These cancel. So I have b is equal to, so 3 minus 3 over 2, so that'll just be 3 over 2. Let's put that back into one of the originals. So I'll put it into b plus c equals 3 over 2. And if you have 3 over 2 plus c equals 3 over 2. So that means c has to be 0. So c is equal to 0. So now we have our general term now. So our Tn is equal to 3 over 2 n squared plus 3 over 2 n. Okay, so that's our Tn term and the nth term. And now going back to the question, we have to find an expression in n for the number of matchsticks needed to turn the n-1th term into the nth pattern. So that would be when I do Tn equal to Tn minus 1. So I have Tn, so now let's get Tn minus 1. So Tn minus 1, let's just replace n with n minus 1. So 3 over 2 n minus 1 squared plus 3 over 2 times n minus 1. So 3 over 2 times n squared minus 2n plus 1 plus 3 over 2 times n minus 1. Expanding this out now, I have 3 over 2 n squared minus 3n plus 3 over 2 plus then 3 over 2n minus 3 over 2. So the 3 over 2s will cancel. And then minus 3n plus 3 over 2n. So let me write the 3 over 2n squared first. That'll be minus 3 over 2n. Now, this is for tn minus 1. So let's equal this now to tn. And tn is 3 over 2n squared plus 3 over 2n. So the n squares will cancel. Let's bring this one over. So we'll have 3 over 2n plus 3 over 2n. 3 over 2 plus 3 over 2. Sorry, the n's as well. That will equal 3n. And there's the expression in n. Okay, and there's your answer to that part, C. Now, for D then, out in the previous part of the n term, which is this one. So we have, let's just write that in. You're told the number of matchsticks in the nth pattern in the sequence can be represented by the function un equals an squared plus bn. So we actually have that done already because it's for matchsticks. And that's what we were. So un is equal to 3 over 2 n squared plus 3 over 2n. With a equal to 3 over 2 and b also equal to 3 over 2. Okay, that's that part done. Now the last part then, so one of the patterns in the sequence has 4,134 matchsticks. How many small triangles are in that pattern? Okay, so what we're going to do is our nth term of the matchsticks, so it's 3 over 2 n squared plus 3 over 2n is equal now to 4,134. Okay, let's times by 2 now, make this easier. So we have 3n squared plus 3n is equal to 8,268. Now I can divide by 3 now as well. So I'll have n squared plus n. Let's bring this over and divide by 3 as well. And I'll have minus 2,756 equal to 0. Now for this, I'm not going to try and factorize because that number's way too big. So let's use a quadratic formula. So we'll have minus 1 plus or minus 1 squared minus 4 times 1 times minus 2,756 all over 2 times 1. Okay, putting this into the calculator now, I'll have minus 1 plus or minus 105 over 2. So this will give us two answers. We will get 52 and also negative 53. Now, we're looking for the term that will have 4,134 matchsticks, and we can't have a negative term, so we have to have 52. And now, so it's in the 52nd term, there's 4,134 matchsticks, but we want to know how many triangles are in this pattern. So the general term we had for the triangles was n squared. So let me just write that down. So for the triangles we have n squared. So we'll have 52 squared. So 52 squared is 2,704. And that's how many small triangles are in that pattern.